Hello teacher, I'm Pedrosa and today I'm going to explain my mistakes on the exam. I already made a mistake on the theoretical part, however I have to explain the procedure of the problem 1 and 2. Let's begin. To clarify, I lost my procedure, so I made a new one. So on the problem 1, it's not going to make the exact number because here I made it with 4 decimals and here is with 2 decimals. However, on the second problem, it's still the same. The problem 1 says, a car traveling on a highway at 60 km per hour accelerates to a speed of 120 km per hour after 2.9 seconds. It maintains this speed for 10 minutes and when it realizes that it is approaching to its toll booth, it brakes completely after traveling 500 meters. We have to determine the total distance and the total time of the travel. So we need to convert these values that are kilometers per hour on meters per second. Once we have this, we can make this a sketch of the trip. So we have here our first section, second section, and third section. So to have the total distance, we need to add all these three measurements. We already have D3, which is 500 meters. So to get D1, we already have initial velocity, final velocity, and time. However, we need an acceleration because we'll need it to get our next formula. But first, we already know that acceleration is equal to final velocity minus initial velocity over time. So we will place 33.33 meters per second minus 16.67 meters per second over 2.9 seconds, which is 5.74 meters per second squared. This is our acceleration. So we'll use now this formula of the squares, that is final velocity squared is equal to initial velocity squared plus 2 times acceleration times distance to get the distance. So we'll solve everything for distance and we have that D1 is equal to 72.56 meters. We have D1 and D3, which we only need D2. This is an easier one because as it is a constant speed, we can use URM. So with this formula, we'll get distance, which is distance is equal to velocity times time, which is 19,1998 meters. Now, to get total distance, it's D1 plus D2 plus D3, which is all these values that we already got, this one, and this one, which will be 20,570.56 meters. I place this so it's more or less the same. Now, the second point says to get total time. We already have time 1 and time 2, so we only need T3. So to get this, I used BF squared is equal to initial velocity squared plus 2AD to get our acceleration. Once we have our acceleration, we'll use now the formula of time because we have final velocity minus initial velocity and now our new acceleration that we already got, we can use it to get time. So we already have time 1, time 2, and time 3, which is this one new, and the addition of these will be 632.93 seconds. So our second problem is much more easier, as it says a bird saw a salmon jumping from the river with an upward initial velocity of 12 meters per second. If the bird catches the salmon on its downward path 0.35 meters above the river, determine the maximum height, the final velocity when the bird catches the salmon, and the total time. So we already have here our values, which is initial velocity 12 meters per second, our velocity when it's on the maximum height, our acceleration, of course, as always, our initial position, which is 0 meters. We need to get the final position on the maximum height, and our final position is 0.35 meters. So on the first problem, which we need to get our maximum height, I try to get first time to then use this formula. So first, we already know time is equal to our final velocity, which is 0, minus initial velocity, which is 12, over acceleration, which will be 1.22 seconds. I wrote here t1 because we need to get a second time, but we'll get into that later. So we will only stick with t1 for now, so we can then use our long formula, which is final position is equal to 1/2 times acceleration times our time squared plus initial velocity times time, which will be a total of 7.34 meters. This will be our first answer. Now for the second one, we need to know the final velocity. I use here this formula of final velocity squared is equal to initial velocity squared plus 2ad. We already have all the values except bf squared, which is the value we are trying to get. And here's a special case because our d, it's not going to be 0.35 because our final position, and this time we're watching it as a free fall. So our final position will be 0.35 meters, and our initial position will be this time the maximum height, which we already got. So it will be 0.35 meters minus 7.34 meters. So this will be our d. And now we will answer final velocity will be minus 11.71 meters per second. Now finally, for our last problem, we need to get a total time. We already have t1, but to get t2, like on the free fall, we will use the formula of final velocity, which we already got here, minus our initial velocity, which is on the top, on the maximum height, our acceleration, which will be 1.19 seconds. And to get total time is t1 plus t2. So in this case, our values are 1.22 plus 1.19, which will be 2.41 seconds. So that's all.